Okay, so we're gonna start on chapter, we're starting on chapter 2 today, which is angles. I'm not looking forward to this. I did not do well at school in geometry. So in this chapter, I will learn about different types of angles, how to measure and draw angles, angle facts and how to use them, about parallel lines, and about bearings. I don't even know what that is. All right, 2.1 Introduction. The study of angles is one branch of geometry, which is concerned also with points, lines, surfaces, and solids. Geometry probably originated in ancient Egypt, where it was applied, for example, to land surveying and navigation. Indeed, the name geometry is derived from the Greek for earth measure. Oh yeah, geo and metry, I guess. It was a Greek mathematician, notably Euclid, who developed a theoretical foundation for geometry. He began his classic treatise, Elements, with definitions of basic geometrical concepts, including angles, the subject of this chapter. So 2.2 Angles. An angle is formed when two straight lines meet, as in figure 2.1. Okay. The point where the lines meet is called the vertex of the angle. Vertex? The size of the angle is the amount of turn from one line to the other, and if not affected by the length, and it is not affected by the length of the lines. The angle in 2.2, the angles in 2.2 are all equal. So it doesn't matter which way which way they face, they all have the same amount of space, right, between the two lines. I think that's what it's trying to say. If you begin by facing in a certain direction and then turn around until you are facing in the original direction again, as in figure 2.3, you will have made a complete turn, or revolution. One complete turn is divided into 360 degrees, which is written as 360 little circle, which means degrees. In a half turn, figure 2.4, therefore, there are 180 degrees. In a quarter turn, there are 90 degrees, which is called a right angle. It is often marked on diagrams with a small square, as shown in figure 2.5. If the angle between two lines is a right angle, the lines are said to be perpendicular. So these are perpendicular lines. Okay. Apart from angles of 90 degrees and 180 degrees, all other sizes of angles fall into one of three categories, shown in figure 2.2. Oh, 2.6. Acute, I'm going to write these down or I'm going to forget. So let's get a new page. So this is chapter 2, angles. With this pencil. Angles. I almost wrote angels. Angles. And this is 2.2, the types of angles. So an angle which is less than 90 degrees is called an acute angle because it's a cutie. So acute. Acute. An angle which is between 90 and 180 is called obtuse. So, right? And then this is obtuse. An angle which is greater than 180 is called a reflex angle. I didn't even think about that. Okay. So it's pretending that it's going all the way around and then like that, right? So the angle is actually going all the way around, and that is called a reflex angle. So acute, obtuse, and reflex. Okay. Spotlight. A useful memory aid is a cute little angle to remind you that angles less than 90 degrees are acute. I'm already one step ahead of you. There are three ways of naming angles. One way is to use a letter inside the angle, as with the angle marked X in figure 2.7. Usually, a small letter rather than a capital is used. So right here. Can you see the little X in there? In figure 2.8, the angle could be called angle B, but you should do this only if there is no risk of confusion. So angle B could be shortened to this symbol in B or B with a little hat on. It could be argued that there are two angles at B, one of them acute and one of them reflex. But you should assume that the acute angle is intended unless you are told otherwise. Alternatively, the angle in figure 2.8 could be called angle ABC or angle CBA. You could shorten this to the symbol ABC or ABC with a big hat on it. The middle letter is always the vertex in the angle. Oh, okay. I gotta write this down or I'm gonna forget again. Okay, so if I draw this figure, and this is line A, and this is line C, and then the vertex is called B. So then it would be angle A, B, C, or C, B, A with a line over top like that. Okay. Exercise 2.1. How many degrees does the hour hand of a clock turn in 20 minutes? Oh no. Okay. Let's do this. So exercise 2.1. How many degrees does an hour hand of a clock turn in 20 minutes? So I gotta draw a clock because I do not. So that'd be what, 12? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So our hand is the short one. So it would be like that. Right? Oh my God. So then what is this angle? If that's 90 and that's 180, that's how I figured it out, right? Right. Help me out here, Chad. Okay. How do I figure that out? How do you figure that out? I feel like it's jumping way ahead right now with me. How would I figure that out? So I would do a quarter, right? More. So if a flat line is 180 and this is 90, this is like that. And it's asking me what angle this is. Right? So it'd be half of, that's 45. So what's half of 45? Am I doing this right? So half of 45 is, I need some scrap paper again. Where did my little, oh, right here. So we do 45 divided by 2. 2 goes into 4 once, which is 2. Am I doing this right? How many degrees does the hour hand of a clock turn? No, the hour hand, not the minute hand. Sorry. Jeez. It was wrong. Anyways. Because the hour hand would only move, because that is the hour hand. So it would only move like, I have no idea. I'll look it up and try to work backwards, I guess. 10? 10 degrees. How do you know that, though? How would you figure that out? I don't think I can do this. I think I'm gonna have to. Okay, so if a full circle is 360 degrees, right? A full circle is 360 degrees. It's asking me, how much does one little chunk? How would you do this? Thinking, how would you do this? So each minute, oh, right, so each minute is at 1 degree. No, each minute is what? What's 360? 360 divided by 60 would be 60. Oh my God, 60 minutes. There's 60 minutes in an hour, and 1 hour. Oh my God. How do you do this? If the answer is 10, how does it equal 10? How do you get to 10 from here? How do you know that it only moves 10 degrees? It has to make sense. What's 360 divided by 10? It's still only, that's 36. So where does the 10 degrees come from? This is why I dropped out of geometry in high school. Okay. We can think through this. We can think through this. We're adults here. I feel like I'm almost getting it. Okay. How would you know it's 10 degrees? Oh, right, because it takes a full hour to move all the way around. Right? So if it only moves 20 minutes, 20 out of 60, which is a third. God, no, I'm not helping myself here. I might have to go teach myself this and come back. Because how would you even figure this out? The answer is supposed to be 10. It's supposed to be 10. It's 10 degrees. 10 degrees. If this is 90, Work out the size of the angle the second hand of a clock turns through in 1 second. How much does it say? 6 degrees. How would you do this? Somebody help me. I know it's something to do with dividing 360 by something. Yeah. 360 divided by what equals 10? Okay, we'll try that. 360 divided by what equals 10? So you times x, so it'd be 10x. So 360 equals 10x. And you divide by 10, divide by 10. That would be 36. So so if one, I don't know what I just figured out. Oh, I think I have to go learn this somewhere else and come back. Because this is not teaching me. This expects me to know. One complete turn is divided into 360 degrees. $100, 360 degrees. So how did we know that it was 36 and 20? How do we know? This is 90 degrees, right? And this is 180. And then this would be, what's 90 plus 180? 270? 90 plus 180. 0. 17. 270. Yeah. And then 360. Okay. We know this. I'm almost there. So there's 90 degrees between these two numbers. There's 90 degrees between these two numbers. Right? So I need to figure out what these are. So this would be 30, 30, and 30, right? 369. That's 360 and that's also 0. And so then 30 more would be 120 and 150 and then 180. I think I'm getting there. Oh, I think I'm getting there. Okay. So this would be 180 plus 30 is, I'm doing it off on the side, 130 plus 8, 9, 10, 11. 8, 9, 10, 11, 20, 210, 240, 270, 300, 330, and 360. Okay. So it's asking me, where is it even now? So it's asking me, how many degrees does the hour hand of a clock turn in 20 minutes? So this has to move along with the minute hand. So it's moving at this less speed. So it moves over what? 4 is 20 minutes. So how do you know it's 10 though? How do you know it's 10? So 20 minutes. So it takes 60 minutes to go from 12 to 1. Right? Yes. It takes 60 minutes to go from 12 to 1. I feel like I'm so close. I feel like I'm getting so close here. Okay. So if it takes an hour, 60 minutes to go from 12 to 1, how far does it get to go 20? Right? I feel like I'm almost there. So 60 minutes to go from 12 to 1. And then it's asking me how much does 20 minutes actually do, right? Because that'd be 60 divided by 20, which is is this making sense to anyone else? 60, but you're actually only going 20 minutes, which is 3, which is a third, right? It's a third. So what is a third, right? Am I doing this? Because 20 over 60 is actually 1/3. And a third of 30 is 10. Am I doing this right? Let's see. Let's see if I can recreate this on 2, which is work out the size of the angle the second hand of a clock turns through in 1 second. The second hand would not, so it would be this. Okay, so the second hand, do they mean as in the hand that marks the seconds, or do they mean the second hand as in like, I'm sure they mean the seconds. Yeah, the seconds hand. Okay, so it's asking the second hand of a clock turns through in 1 second. So it just moves like 1 over. And there's 60 seconds in a minute. Oh my God. Okay. Work out the size of the angle the hour hand of a clock turns through in 35 minutes. Okay. So I think I might need a calculator for this. So because it would be 35 over 60, which equals what? How do you break down fractions? I feel like I should know fractions for this, and I do not know. I think I have to look up how to break down fractions. Okay, let's go back. Let's go to time. Work out the size of the angle the second hand of a clock turns through in 1 second. So it just moves like 1 tick. It moves 1 tick over. So is that like 1 degree? Is it 1 degree? No, it's 6 degrees. How is it 6 degrees? How is it 6 degrees? And then the third is 17 and a half. I'll write that down over there. Okay, so let's try to work backwards again. So we know it's 6 degrees. How do we get to 6 degrees? So there's 60 seconds in a minute, right? Work at the size of the angle the second hand of a clock turns through in 1 second. So it just like moves over. So it should be like 1 degree. Chat, I need some help here. Is there any mathematicians watching right now that can explain this to me? I don't think so. Okay. Work out the size of the angle the second hand of a clock turns through in 1 second. How is it 6 degrees? Okay, so I'm just gonna get my calculator out here. So 360 divided by 60 is 6. That's how. So 360 divided by 60 is 6. So it's 6 degrees because it's just doing one little section. Okay, that's making sense to me. Okay. Okay, that's making it's starting to make more sense. Because one little section is 6 degrees somehow. Okay, work out the size of the angle the hour hand of a clock turns through in 35 minutes. So this is going like this. The little hand is moving a bit. It's moving like just over halfway. So it has to be just over half. It has to be just over half of 60. So is it 60 divided by 35? Right? That makes sense. What is 60 divided by 35? 60 divided by 35 equals 60 divided by 35. That doesn't make any sense. Okay. Because the hour will just be somewhere just over halfway. So it'd have to be like 30. What's half of 30? That's what I should be doing. So it's 30 and 60 and 90. 30, 60, and 90. That's what's throwing me off. 30, 60, and 90. So each one of these is 30 degrees. Okay, it's all coming together. Okay. So it's asking me $35 would be over here, which is over halfway between these two. So it's just over halfway to 30, right? Yes. What's just over halfway? So it'd be okay. So it's moving over while this hand is moving, right? And 35 minutes is just over half an hour. So it would have to be just over halfway between the 12 and the 1. But where would it be? So how do we figure that out? So 35 divided by 60. So 35 divided by 60 times 100. It's 58%. 58% points, 58.3%. So the number is going to be 58.3% of 30, right? What's 58.3% of 30? What is 58% of 30?
The answer is 17.4.
Okay. What is 58.3% of 30?
The answer is 17.49.
I'm getting it, but I don't get it. Because what it's asking is how much over is this hand going to be when this hand is all the way over here? And I know it's just over 50%, right? Because 60, 35 is 58.3% of 60. So we actually have to know what 58.3% of 30 is. And that equals 17.49. So we'll say 17.5, which is the answer. So I think I'm getting it, but I still don't get it. I still don't get it. Let's keep going. Nobody said learning was easy. So then we look at number 4. Work out the angle the second hand of the clock turns through in 55 seconds. So we just do 55 times 6 because we know that there's 6 degrees in each second. So do we do that? 55 times 6 is what? What is that? 35, and then 6 times 5 is 35 again. No, it can't be 30. It's 30. So it'd be 330 degrees. In theory. Is that what it is? Please, please tell me I'm understanding something. 330. Thank you. Okay, number 5. Work out the size of the angle between south and west when it is measured A clockwise and B counterclockwise. So never eat shredded wheat. So what is the size of the angle between south and west when it is measured clockwise and counterclockwise? So it's 90 when it's measured, wait, which way is clockwise? This way. So if we're measuring that way, that would be 90. But if we're measuring no, that's clockwise. If we're going counterclockwise, there we go, counterclockwise, that would be 270, right? That's what we decided 3 of them were? Yes. Okay, that's A and B. 6. Work out the size of the angle between west and northwest when it is measured clockwise and counterclockwise. So never eat shredded wheat. And then northwest would be here, northwest. So it's asking, work out the angle between west and northwest. So that's a 45-degree angle when it is measured clockwise and anti-clockwise. So it would be 45 degrees. And then it would be whatever this is. So it would be 360 minus 45, which is what? 360 minus 45 is minus 45. 315. Okay. 7. State whether each angle drawn below is acute, obtuse, or reflex. So A is obtuse. B, reflex. C, acute. I don't know if you can see them. D, acute, no. Obtuse. B, reflex. 8. State whether each of the following angles is acute, obtuse, or reflex. So A is 172, which would be obtuse. B, 203 would be reflex, right? Let's go back here again. Yes, reflex. C, reflex. And D, acute. 9. Use capital letters to name the angles X, Y, Z, and T in the figure. So X would be M, L, N. Or N, L, M with a little hat on top of it. Y equals L, L, M, N, or N, M, L with a little hat on top of it. Z equals B, A, D, or bad, or D, A, B with a little hat. And T equals C, B, A, or A, B, C with a little hat on the top of it. All right, let's see. I know these ones are right because I already looked at them. I think I understood. I think I got it. Okay. So 5 is 90 and 270. Yes. Oh, sorry. 4 is 3. Yeah, I think I already did that one too. And then 6 is 45 and 315, which is what I got. And then it's obtuse, reflex, acute, obtuse, reflex. And then obtuse, reflex, reflex, acute. And then L or AMLN. Oh. Well, I got that one right. Oh. Sorry, that went off. And then M or LMN. I got that. A. I knew the angle was A or bad. And CBD. 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 What did I do? C, B. Oh, yeah, my bad. Because the angle is B, I know that. Or C, B, D. My bad. All right, that was terrible. But I worked through it. I figured it out. It took me a long time, but I did. And I'm very proud of myself. So yeah, that was the first exercise 2.1 in the angles chapter. My brain hurts, but that's part of learning. Thanks for joining.